Recording in progress.
Okay, in the last session, we have seen JMS application. Today, I am going to give some code explanation. Observe carefully here. We wrote two applications, producer and consumer. We have added ActiveMQ dependency here. Okay, you can just see the API details here. Sun microsystem, of course, now part of Oracle, has provided JMS API. Is a vendor implementation to JMS, Apache ActiveMQ file. Okay, we are developing applications. So here, API provider is a Sun microsystem. Now Oracle, API name is JMS API. Okay. Apache has provided implementation name ActiveMQ file. Okay. If you go to producer service, there we used JMS template and send method. Okay, and it is taking message creator. We have a parameter called session. Look at session is a interface. Session is an interface which indicates a standard connection successful between producer and consumer in this package. Okay. You can just see here. But we need an implementation for session that is given by ActiveMQ session. org Apache ActiveMQ is a package. Session is an interface. This is implementation. That is fine. Now you can see again message is an interface. It is also in javax.jms. It has one subtype that is text message. That is also interface for this implementation given by again ActiveMQ text message. Now observe. Actually, we are using session and creating the message. These are the API details I'm just showing here. This is a class. Okay, send method is taking second parameter message creator, where message creator we are using session and returning the message. If you look at it is completely working on JMS API. There is no dependent on ActiveMQ. Okay, even in the code also we used completely JMS API. There is no ActiveMQ import statement you can see anywhere. Okay, so the work of the message creator by using session, okay, it is actually going to create a message and returns. Okay, so in the session, there is actually one method available, create text message. You can see here. There is a method line available inside the session. Okay, so but for this interface, implementation is ActiveMQ session, right? There is a class ActiveMQ session that implements session. These are all predefined classes. Just I'm showing here. There it has overridden this method. Okay, and where text message is again interface. Okay, for that it is using implementation. And written this one here. Like this logic is created. When you take a super type reference here, and here internally it is creating like this session is equals to new ActiveMQ session. When you use session parameter, internally it is taking implementation class object, and you are calling here, okay, programmer is actually calling session dot create text message, and just you are passing some hello. Okay, that return type is actually text message, and the super type of text message is message. So here you can see it's a message. This last line I wrote. Session dot create text message. It's a lambda expression here that we are just passing here. Okay, because of this internal code here, you can just see the implementation. Above interfaces are given by Sun Microsystem. Below implementations given by Apache Company ActiveMQ. Session given by Sun Microsystem. Even message and text message session, this code. ActiveMQ session and ActiveMQ text message given by ActiveMQ. These are all predefined classes and interfaces here. Now by using them, what I am just doing here, look at. So here, now Spring container involved. Spring containers is actually here. This line, I'll do it. Okay. Then session object is created. Okay, finally, what programmer is doing here? Okay, Sun Microsystem gave interfaces. Okay, Apache ActiveMQ gave IMTLs like this. Spring container created object. Programmer calling method. Okay, so what is the method we are just calling here? I am taking session, calling this create text message, return the text message and casting to this one here. Observe. By using this line. Okay, there is an interface available message creator. You can just see. For this functional interface, Spring has given this one. Spring container. And now programmer work. Okay, if you look at this one, I am writing a lambda expression here. Lambda expression syntax. Okay, here that is interface OB is equals to method parent, interface name message creator. Okay, something like a message creator I'm just writing is equals to method parent. Remove the data type and method body. Okay, in the method body I am using the session dot. In the session, if you look at here, there is a method available create text message. Passing some text here, something like hello. Okay, that return type you can see, it's a text message. Text message PM. But it is casted to super type message and return. Okay. Now here, the same thing in short format. No need parenthesis, no need curly braces, no need return statement. This one. So here understand, Sun Microsystem gave interfaces already. Apache gave IMPLs. Spring Container gave object creation and one functional interface. Programmer wrote lambda expression. Okay, already 95% work is done. Just remaining 5% work we are just doing here. Okay, if you don't want to write lambda expression, you can write even anonymous syntax also. If you want me to show here, so here jms template dot send destination name new interface name message creator and press enter. Anonymous style here, override the method. Same line you write here inside this over. This is anonymous style, this is lambda style. Destination name new interface name, override all abstract methods, same line. Okay, so here you can see again I'm revising for a second. Look at carefully, revising for a second. Observe here, Lambda is recommended over anonymous. Okay, now see, first Sun Microsystem gave JMS API. Okay, they gave interfaces. That is, interface name is called session, interface name called text message, interface name called message. Okay, and if you open the session interface code, it looks like this. Next, Apache, they gave implementations for these interfaces. They gave implementations named as ActiveMQ file, session ActiveMQ session, text message ActiveMQ text message. If you open and look at here how the code looks, just implementing the session, overriding the method. Okay, so Sun Microsystem gave interfaces, Apache gave implementation. Now Spring Container says, I'll create the object. Happy. Which object? Session object. Session reference implementation class object created by Spring Container. Now they are finally calling to you, finally they are informing to you, write a Lambda expression for a functional interface given by Spring Container. Okay, Spring Framework, Spring JMS, they gave an interface name called message creator. They are just saying, write one implementation for this that will take the session and create the message and send it. By taking some destination name, it will transfer. Okay, now finally programmer duty. Take this interface and write the implementation. Lambda expression. Here you can just see, we are writing the Lambda or anonymous type. Anything is fine. Okay, so message creator, override the method or parameter and method body. Actually our code is single line only, but to make it single line, inside lot of content is there. Okay, that's why I gave in the diagram format. Even after class completed, you can check one by one. 1, 2, 3 predefined, fourth one your work. Okay, now if you observe here, it's a producer service. There we have JMS template. Observe. JMS template, it will reduce boilerplate code, means common code. Okay, that is creating session, okay, creating message, casting to type and send to destination. Okay, they just take inputs and send a message to destination. It's a reduced code. So whatever the logic you have tried somewhere, all this code, right, that is actually available inside the send method. Okay, creating the destination here, do send method logic is there. If we just track here, lot of work is there. Message creator, create message. Okay, check all the things here, create producer, producer record, lot of things are there inside. Okay, so they have code which is actually no need to write again and again. In pure JMS, of course nowadays no one learning, there is a pure JMS code. That pure JMS code is this one. Like you used to learn pure JDBC program, right? Okay, So like pure JMS code was there at that time. We used to do all these things manually, but now it is actually automated. Okay. Now Spring Container is actually saying, okay, don't worry, I'll take care of these things. Okay, by using the session, creating the message and all here, they made us some predefined logic here. Okay. Now, if you want to make this application as a peer-to-peer communication here, just change this value into true. Okay, same thing, same value, you have to change it into true at the consumer side also. Then it behaves like a PubSub. Entire code is same. True means PubSub. False means peer-to-peer. Okay. So here with the same destination name, one topic will be created. You can copy paste this project and create one more consumer also. No issue. First you run ActiveMQ software. See the default value here. This is false. If you don't write the key, this is default. Consumer started and waiting for listening here. Producer started and sending the content here. There is a topic created here. My data, you can just see in the bottom topic section. My data created, sending the messages and receiving the messages. You can write same one more consumer as it is code copy paste. There also will read the data. It will read the data. No issue in that application. Same message will come there again. I'm just stopping here. Consumer 2 I'm just taking. Apache ActiveMQ5. Next and finish. Same keys I'm just doing copy paste here. From consumer to, I'm just writing like this. Okay. At starter class, we have to write one annotation here, enable JMS. In the latest version, it is optional, but most of the applications you may see this, so write it. This is consumer 2. You need not to do like this, but I'm just showing the confirmation for you. Okay. Yeah, these are two different workspaces, just for clarity. This much complication not required, just I'm showing here. Same message will be sent to two places. This is consumer 1 and consumer 2. I should have modified here consumer 2 also. See here. Okay, I'm not doing anything, just started applications and sitting silent. When producer will send the data, consumer will read the data here. You can see the number of consumers 2. Number of consumers 2 here, you can just see here. Okay. Entirely same code, nothing different. Just another workspace. Okay. Just I am giving here. We can define one new consumer application at another workspace. Of course, same also fine. But you cannot check console properly. Okay. With all keys and code as same. Just to mention true. Then run ActiveMQ consumer and producer applications. One message will be sent to multiple consumer here. Okay. So here NQ and DQ nothing but actually entered into Q and received from Q. Okay, that's actually here. That is ActiveMQ software. Okay. This is ActiveMQ software. Entered into Q. This is NQ. Okay, reading from Q. It's a DQ. That's the meaning here. NQ, DQ meaning here is this one. Ignores concept of queues and topic. Software, mom software. Is that entered or not, or received or not here. That's the meaning. But ActiveMQ has some limitations. In real time, mostly Kafka is used. what are the limitations and why we work with a Kafka, okay, that we are going to see in tomorrow's session here. Okay, so ActiveMQ, learn for practice and basic purpose and leave. We completely work on Kafka programming. Okay, so thank you for session. We'll continue the tomorrow's class.